Hello and welcome to release question number 42 for the CST release questions for Algebra 1. It says which ordered pair is a solution to the system of equations shown below. And so they give us these answers. Could we take all these answers, plug them into both equations, and see which one worked in both equations? Yes, it's a multiple choice test. That is something we can fall back on. However, I don't want to depend on that. I don't want you to depend on something like that. I want you to be able to actually figure out the answer to this problem even if the answers weren't here, if the possible answers weren't here. So I want to start by using something called linear combination. We could use substitution. We could solve one side for x or y, plug that in to the other equation, and then solve for the variable that you have left. But with this one, I think it's a little easier to use linear combination, where we take one of these or both of these equations and change them in some way so that when we add them or put them together, they still, or you get something to cancel out. So this one, I'm not going to change this one, but I notice that if I were to have x here and a negative x here, then the x and the negative x would cancel out when I put the two equations together. And so this one I want to multiply by -1. So I'm going to take this whole thing, this whole equation, multiply everything by -1. I'm not going to change this one. So that would leave me with x plus 3y equals 7. Down here I'd have -x minus 2y equals -10. And so now I'm going to put these two equations together. If you think of, this is just to help you understand why this works, think of science class. You've got stuff that you put on a scale that balances out on both sides. Let's say you had some weights over here that balanced out with some weights over here. That would be like one equation. The green equals the green. Both sides equal each other. And if I add something more to these sides, if I put another equation, these two things were equal weights. If I put two equations together, green equaled the green, the purple equaled the purple. If I put them together, green and purple together with green and purple, they should still balance out in the same way. If I put two equations together, that's what I'm doing here. I'm putting this equation together with this equation. If I put them together, they should still balance out. They should still equal each other. This is a good analogy to help you understand why that works out, I think. So I've got x canceling out with -x. So I'm putting the left sides of the equation together, just like I put the left sides of the weights together over here. That will be y is what I'm left with, just a 1y, which is just plain old y. And now I'm putting the right sides of the equations together, just like I did over here. 7 minus 10 would be -3. And so it looks like -3 should be our y value. And that eliminates choices A, B, and C. So let's just make sure, though, let's make sure that 16 is in fact the x value. So if I take now either one of these equations, I'll go with this one. They both look about the same in terms of the difficulty level of plugging in the value for y and solving for x. And so I'll choose this one. I would have x plus 2 times -3. Notice I just plugged in -3 for y equals 10. So I have x minus 6 equals 10. If I add 6 to both sides, this will give me my final answer, x equals 16. It'll give me the last part of my final answer. So I've got an x value of 16, a y value of -3, just like I expected. That one had to be the answer, and it was choice D for number 42.